Hello. Today we're going to be starting Unit 5, which is all about quadratic functions. So the first part here is all about graphing quadratic functions. Now, in order for something to be quadratic, it has to be written in the form of f of x equals ax squared plus bx plus c, or it has to be able to be written in that form. The a value is always in front of the quadratic term, the x squared. The b value is always in front of the linear term, and then the constant is always just the number with no variable at the end. If you have something that can be written like this, your graph is going to be a parabola or a U-shape. Now the vertex is going to be that turning point where it goes from like going down to going back up. It will always be the highest or lowest point. To know if it's going to be a highest or lowest point, you have to look at your a value. It's all based off of that a value. So if a is greater than 0, aka positive, then your graph is going to open up. And therefore, the vertex is your lowest point, known as a minimum. Versus if a is negative, the graph gets reflected over the x-axis and opens down, and your vertex would then be the highest point, known as the maximum. The axis of symmetry is going to be a vertical line that goes through the vertex. It's always going to go through the vertex, and it's going to be symmetrical on both sides, your parabola will be. Your axis of symmetry, since it's a line, it's always going to be at x equals some number because it is vertical. And so if you know what coordinate your vertex is at, it's always going to be the x value of your vertex. That will be x equals that number for your axis of symmetry. For your zeros are known as many different things. So you need to know the term zeros. You also need to know that they are called the solutions or roots. So all of those are saying the same thing. So zeros, solutions, or roots are written as x equals some number. So it's kind of like you solved an equation and you got an answer. They are going to be the same thing as the x-intercepts. So the x-intercepts are the zeros, the solutions, or roots. The only difference is if I ask for the x-intercept, you're going to write it as a point, some number comma 0. Whereas if I asked you for a root or a 0, you would write it as x equals some number. So let's take a look at a couple examples here, and we're going to find all of this information based off of this graph. So for this first one on the left here, we can see the graph opens up. This point down here is the lowest point, known as your minimum. That point is your vertex. So that is at the point 0, comma, about negative 4.5. It's just an estimation at that point. Your domain for all quadratic functions is going to be the same because left and right, your graph goes for forever. So it's negative infinity to positive infinity. Range goes from low to high. So our graph gets down to negative 4.5 and it actually touches it, so it's a bracket. And then it goes up for forever, so positive infinity. Your roots and your x-intercepts should match. It's just that the x-intercepts are written as coordinate points, so negative 3, comma 0 and 3, comma 0. But the roots are going to be written as x equals negative 3 and x equals positive 3. Your axis of symmetry is this vertical line here that goes through the vertex. So it's going to be x equals, and for this one, it's always going to match your x value of your vertex. So x equals 0. And then these last two things are new to us, the interval of increase and the interval of decrease. This is asking, where is the graph going up or down? That's what this means. Where is the graph going up or down? Now, when you answer this, you're always going to answer from left to right, just like your domain. And then also, this is always going to be in terms of x. So let's take a look at this first one. So if I start all the way at the left of my graph and I trace my vertex, this is decreasing here. So it's decreasing on this half of the graph. At my vertex, I turn and now I'm increasing from there. So from left to right, all the way left on our graph is negative infinity. Oops. So I'm starting with decreasing, so I'm going to put it down there instead. So I'm starting all the way on the left, decreasing, and then I stop here at my vertex, but I'm looking at my x values. So on the left of the screen here is negative infinity, and then at 0, which is the x value of my vertex, I stop increasing or stop decreasing, and then I start when x is 0 and go to the right, and that's my increasing intervals. Okay, so left to right using x values only. Where are you decreasing and where are you increasing? Another note here is that the value you use, 0, will always have parentheses, because a point itself cannot be increasing nor decreasing. So it's not going to be included in either one of those. So what I'd like you to do is take a moment and try the next example, and then I'm going to pop up and show all the examples or all the answers. So pause the video, try it yourself, and then I'll show the answers in just a sec. We have the vertex being negative 2 comma 9, its maximum, domain negative to positive infinity, range negative infinity to 9 with a bracket. Roots and x-intercepts are both when x is negative 5, and the axis of symmetry is x equals negative 2. For increasing, I wanted to show that one more time just in case we wanted to see it again. So increasing and decreasing go left to right. I'm starting out with my graph increasing. I turn it around here and then I start decreasing. So the time when I change from increasing and decreasing happens when x is negative 2. As a reminder, on the left of your graph is negative infinity for your x values. On the right is positive infinity. So the increasing happens from negative infinity to negative 2, whereas the decreasing happens from negative 2 to positive infinity. Even though it's going down, I know it's going down. That's what the question is asking. So it's pointing towards negative infinity, but your x values are still getting bigger because you're going to the right. So we are able to take a graph that's already given to us and analyze it. But what happens if I take away the graph and give you the equation? Now, graphing from standard form, this will be done without your calculator. Will be on a no calculator portion of a test or a quiz. So to find your graph, what we're going to do is we're going to start off by finding the x coordinate. You're going to do negative b over 2a. And as a reminder, a is in front of the x squared, b is in front of the x, and c is the constant. Once you know negative b over 2a, that is the x value of your vertex. We're going to find f of negative b over 2a. That's a fancy way of saying do the GLADE and plug it in, okay? So you're going to plug in x to find your y value. So then what's going to happen is you're going to have some sort of a graph where you have the highest point or lowest point. But then you need to know how to graph after that. So quadratics always follow this pattern, 1, 3, 5, and it would keep going with 7, 9, and so forth. So normally you would go over up 1 and put a point. And then you'd go over 1, up 3, and put the next point, and then over 1 and up 5 and put the next point. But what happens is our a value is going to stretch our graph. So what we're going to do is we're going to do 1, 3, and 5 times your a value, and that tells you how far to go up or down each time. So for instance, if we had y equals 2x squared, we would take 1, 3, and 5, and we would multiply them all by 2. So we would go over 1 up 2, over 1 up 6, and over 1 up 10. Basically, everything would be stretched vertically by a factor of 2. And so your graph of your parabola would then look more stretched out. Whereas if you had y equals negative 1/2 x squared, your a value is negative 1/2. You would take that 1, 3, and 5 and multiply by negative 1/2. So you'd go over 1 down 1/2, over 1 down 3/2, and over 1 down 5/2. So that's going to change the way your graph looks. And so what happens is it gets flipped over and it gets kind of compressed versus stretched out. And so based off of those two things, then you actually get a good picture of your parabola and you can answer all of the other questions from there. So let's take a look at number 1 here. So we are going to find our vertex and the way it opens and our axis of symmetry, all based off of your A, B, and C. So your A value is -3, your B value is 6, and your C value is 3. So it opens all depends on your A value. Since A is negative, that means it's going to open down. To find the vertex, we're going to do x equals -b over 2a. So 6 is positive, it's going to become -6 over 2 times -3, which is really -6 over -6. So it's x equals 1 is the x value of our vertex, which means it's also going to be our axis of symmetry here, because it has to go through our x value of our vertex. To find our y value, we're going to take 1 and plug it in, and again, this would be no calculator. So we're going to do -3 times 1 squared plus 6 times 1 plus 3. And so now we're going to do order of operations. We're going to square this first and then continue on, and we're going to end up figuring out that our y value for this one is 6. So we have 1, 6 as our vertex. So then to figure out the rest of the information, we're going to go ahead and graph using our 1, 3, and 5 pattern times our A value. Our A value here was -3, which means these numbers are going to become -3, -9, and -15. So from my vertex, I'm always going to go over 1, and then this one is saying I want to go down 3 from my vertex. From this point, I go over 1 and then down 9. And then from here, I would be off the graph grid. So my graph looks like this. Once I have my graph, I then can answer all of the other questions here. My y-intercept is 0, 3, and your y-intercept should always match your constant, because if you plug in 0 for your x values, you get that constant back out. Your domain here should be -infinity to +infinity. Your range is -infinity to 6 with a bracket. Increasing starts on the left for forever and stops here when x is 1. So it's -infinity to 1. And then it starts decreasing when x is 1 and it goes to the right for forever. I've saved my x-intercepts because looking at this, my x-intercepts are these points here and here. So I don't actually have exactly what they are right now. So this is the only spot you can use your calculator for if they're not nice. So you type that in on your calculator. You can take a moment to try that and hit second, calculate your x-intercepts. You should get -0.41, 0 and 2.41, 0. Okay, so for these next two, what I'd like you to do is calculate your vertex for each of these. So take a moment, pause the video, do x equals -b over 2a for each of those, and plug it in, and do it all with no calculator. All right, let's see how we did. For number 2, we get the vertex of 2, -9. For number 3, we get the vertex of 1, 4. Be careful with that one that the -1 stays out in front, and you square just the +1 that you got, and then you keep going from there. So now take a moment, and what I want you to do is that 1, 3, and 5 pattern times your A value and graph that and see what it looks like. So here we are with the first one going over 1 up 2, 6, and then 10, and with the second one going over 1, down 1, then 3, then 5. So with these ones, then you can calculate all of the other information. I'll post the answers here in case you're curious on what those are. And then if you have any questions, let me know tomorrow when we're kind of going over this again. Okay, thanks.